All right, good morning, everybody. So this week, our theme is object-oriented programming. So that's what we're going to continue learning. Although, actually, to be honest, we're going to have to take a slight detour this morning. Going to have to show you something that is not quite directly related to OOP, but it's going to be important. There is a somewhat advanced feature in Python known as decorators. And this is also being added to other languages. Like this is a brand new feature that's going to be available in JavaScript pretty soon. So this is kind of a cool thing that's good to know about. But it's a classic traditional feature in Python. It's existed for ages in Python. And again, it's not directly related to object-oriented programming, but as we get deeper into OOP, we're going to find that OOP in Python uses decorators in various situations. And like I've said before, I really hate showing you code that you don't understand. I believe that you should be allowed to understand everything you see on my screen, on your screen. I don't want you to just type the code to make it work and you don't really understand what's going on underneath the hood. So we're going to take a few minutes this morning just to understand decorators and how they work, how we can create our own, so that when we're using the decorators that Python provides to us for our object-oriented classes, we're going to actually understand what's happening under the hood instead of just treating it like magic that we don't understand. So this here is a very brief description of a decorator. I'm sure you can't visualize it just based on this description. So we're going to see some examples. But long story short is that sometimes you are going to write a bunch of functions that you need to modify their behavior in some systematic way. So an example I'm going to show you later is if you want to profile your application, understand why it's so slow, we could decorate our functions so that they print out the current time when they run. Now, I wouldn't want to add that to the definition of the function because that's kind of it's not really like part of the core logic of the function. It's just this extra work that I want to happen when I run a whole bunch of my different functions. So I could, for example, decorate my functions so that they print the current time in addition to doing whatever else it is that they do. All right, so let's actually write some code here. So the first thing that I think many people struggle with when trying to understand decorators is just the concept of a function that returns another function. So this is not something that we've had to do yet, have a function return another function. It might seem a little bit odd at first. You might have some trouble wrapping your head around the concept. So that's understandable. We're going to take this slowly. I want to clarify one thing. The reason why this works, the reason why this is possible in Python is because there is a specific feature in Python that, what should we call it? So Python has what's known as first-class functions, or another way of phrasing this is we can say that functions in Python are first-class citizens. Has anyone heard this terminology before, first-class function in programming?
Yeah, it was mentioned in the notes somewhere that JavaScript was a first class something. I don't know if it was a first class functions, but first class something.
Okay. So I'll understand if you don't know what it means to be a first class function. But let's just kind of think about this metaphor for a second. What does it mean, what does it mean if you live in an oppressive police state to be a first class citizen?
Free from oppression.
Okay. What if what if you're not a first-class citizen? What kind of restrictions does that put on you?
Seems hierarchical. You know what I mean?
So I guess more concretely, if you're a second-class citizen, maybe you can't go out at night. There's a curfew, you have to be indoors after hours. Maybe you get stopped at checkpoints on certain highways where other people can just drive right through. You get your papers checked. Long story short, you can't go anywhere. There are restrictions on where you can go and when you can be there. Whereas a first-class citizen can go anywhere that any citizen is allowed. And so similarly in programming languages, if your language supports first-class functions, that means that you can put a function anywhere that you could put any other type of value. So some programming languages are more restrictive. Like some languages might let you only define a function in its own file, or you can't define it as part of another statement or inside of an if statement or whatever. Some languages don't let you pass functions as arguments to other functions. They don't let you return functions from functions, because in some programming languages, functions are a special type of value that can only be used in certain limited situations. So Python is not one of those languages. It's also similar to JavaScript in this regard. Both Python and JavaScript have first-class functions. So this means that just like you can pass a number into a function, create a number in that function, return a different number from that function, you can also pass a function into a function, define a new function inside of that function, and then return that function from your function. So I know I just said the word function like 11 times in the last sentence, so it might be a little bit hard to follow. But this is the magic of first-class functions, is that they can go anywhere. So let's get a quick demo here. Again, this is not a decorator, what I'm showing you initially. I'm just going to show you a function that returns a function. Okay, so I'm going to make a function here called widget maker. So I don't know if anyone in here has heard of widgets before. It's just kind of a generic thing that you can manufacture. It's not any specific product. So this is going to be a generic function that just makes generic things. Well, actually, this function does not make widgets. So let me clarify.
Zach, your mic's hot.
Oops. So this function does not make widgets. Rather, it will create functions that create widgets. So I'm going to show you a function that defines and then returns a function. Okay, so inside of my function here, I'm going to define another function because we have first-class functions in Python, so I can define this anywhere I want to. Here I'm going to define widget maker. So this function will actually create widget objects. And here's what those are going to look like. I have a type. All of them are of type widget, not super interesting, but the color is going to vary. I'm going to pass in the widget color. So our widget maker is going to get the color passed in, and then it creates widget makers that can only create widgets of one color. So this widget maker here doesn't take any arguments. Every widget it creates is going to be whatever was passed in here. And then at the end, we will return widget maker. So this function that we are defining inside of widget maker, we are defining that function and then returning it. So now I can actually create a widget maker. Let's say red widget maker equals widget maker red. So now I have not yet made a widget, but I have created a function that can create only red widgets. So I'll say red widget equals widget maker, and then this doesn't take any arguments. It only makes red widgets. Say another red widget. I'm going to call the function again. It's not going to be super interesting though. All right, so let's see what our widgets look like. Cool. So the first one tells us it's a function. That's what I expected, because it was not actually a widget maker. It wasn't actually a widget. It was the widget maker that we created from our widget maker. But then below here, we've created two red widgets by just calling the red widget maker. No arguments, because it can only create red widgets, because that was the argument that was passed in to the widget maker when we created our red widget maker. So similarly, I could make a widget maker for other colors. All right, so here I'm showing you that I've created another widget maker, but this one only creates blue widgets, and then just calling it plainly, I'm able to create a couple blue widgets. So they just have color blue. So this should be a relatively basic example. We're gonna build off in some more complicated functions, defining functions in a second, but I just wanna make sure that we're on the same page. We're able to follow this example with how I have defined this function inside of the function, and then I return this function, which I then use throughout my program. What questions do we have? Michael, did you raise your hand?
Yeah, so I was just curious. So when you put red underscore widget equals red widget maker, do you have to put the parentheses at the end of red widget maker since it's referencing another function, or how does that work?
Exactly, because I want to call the red widget maker, because this is a function. I'm not just referring to it. Because if I just said red widget equals red widget maker without these parentheses, basically that's just saying that this red widget is another variable that refers to the same function. I've copied the variable in a sense. But that's not very interesting. That's not very useful. So definitely the reason why I define a function is because I want to call my function. So I need these parentheses after it in order to invoke the function and make it actually do what it's supposed to do, which, because this is my red widget maker, it's this. So this is what it's actually doing when I call red widget maker. Sound good?
Gotcha, thank you.
What other questions do we have?
Yeah, unless I'm not understanding something, haven't you always been able to create a function inside of another function? Like, aren't they just nested functions?
I mean, yeah, Python has always had this functionality, but did you know you could do this?
Well, I think I was referring to JavaScript. I don't know too much about Python anyway.
Oh yeah, you can do this in JavaScript too.
Yeah, I didn't know Python could do it.
Yeah, it's maybe a little bit less obvious in Python, but Python definitely supports the same kind of like functional styles as JavaScript if you really want to write your code that way. And for decorators, it's necessary. What other questions do we have?
So you used, I guess it's title case for both the widget maker and widget maker.
Mhm.
Is that convention and why, I guess?
That's a good question. I'm actually not confident if this was the best way that I could have written my variables. Definitely for like classes, it's very common that you use title case like this. And I guess because this is a function that like creates things, it's a constructor, I kind of use that convention. Maybe it would have been better to use snake case underscores. I'm not really sure. I did want to differentiate the functions that are creating our widgets from the widgets themselves. Yeah, I wouldn't think too hard about the variable names in this case. What other question do we have?
I'm kind of struggling to see like a why you would prefer to do this over, I mean, because you are creating your own functions, so it's like you're going to have to do it anyway, right? So you could make widget maker its own function and just return just like that, return type widget color, and take in the parameter widget color.
Well, maybe you don't know up front which colors of widgets you need to make, and so you want to, but
Oh,
you
so
know
it's
you
like
want to have a dedicated widget maker that only makes one color widget. I guess it's not really a practical example. So
it
there
looks
is,
like you're programming for programmers almost.
well, I mean, I am. So yeah.
I think Skylar's saying like, looking at like line 4, you could have been put a parameter of like color, and then it literally does the exact same thing, right?
Right. So there is an extra level here that's perhaps unnecessary in this specific example. I could have written a function that just takes in a color and then returns a widget of that color. But I specifically want you to see just how we can pass an argument into a function that gets used in the function that's defined internally, even though it's not passed in as an argument. I just want us to be clear on how the code is flowing and how we're able to access our data inside and outside of the function. We'll definitely get to more useful examples in a minute. Francisco?
Yeah, so I think I saw an example of this. I'm not sure if it exactly applies. And I just don't want to get them too confused. So I saw it on Codecademy where it was like a button on JavaScript. And then, so like the function itself was repaint background. And then inside of that function, there was a function that would like randomize the colors. And then that was all attached to an HTML file where you would like press the button called repaint, and then it would go through both of the functions. Is that kind of like the way this is working?
Maybe. I'm not sure if I followed you 100%, but that sounds a little bit different.
Okay, got it. Thank you.
Why don't we just, let's continue. See what we can learn. Justin, you have a question?
I have all the questions. That's okay. We'll see where this goes. Go for it.
Okay. So let's continue now. So here we're going to actually make a decorator. We're going to use dates a little bit. I told you that example of recording timestamps with our decorator functions. So don't worry too much about how datetime works. This is just going to be used for printing out the current time. So now I'm going to create some basic functions that I might want to decorate. So add 1, you're going to pass in a number. It's going to give you that number plus 1. Not super exciting. Similarly, got multiplied by 2, takes in any number, returns that number times 2. Okay, so now I want to show you our decorator function. So first things first, our decorator function is going to take a function as input. So like I said, the purpose of these decorator functions is to modify some other function. So it's going to take this function as input and then return a new function that is slightly different from the one that was input. So I'm going to define that inner function now that is going to be returned later. Call this a wrapper function. It's kind of a generic name because it's wrapping this input function. Now this is such a generic function that I'm going to declare the arguments just star args and star star keyword arguments.
Can you elaborate on what those mean again?
So star args means that this function can accept any number of positional arguments, and star star kwargs means that this function can accept any number of keyword arguments. So the reason why I'm doing that here is, so inside of the wrapper function, I want to call the function that was passed in. But like I need to make sure that this wrapper function has the same function signature. You know, it takes the same arguments as whatever function is passed in. But I don't want to actually have to tailor my decorators specifically to the function that they're decorating. I don't want to actually like set this function signature to be the actual arguments that the decorated function expects. Instead, I can just say star args and star star kwargs so that this is generic enough that it can decorate any function, no matter what positional arguments or how many it's got or how many keyword arguments it has. This syntax is going to accommodate any function. But right now, this is not very interesting. All this does is just call the function that was passed in.
Are you making a function that creates functions?
That's what I'm doing here.
Okay.
So I've created a function, print current time and also, that takes a function as input. And then inside of here, we define a new function called wrapper function, which calls the original function. And then we return the wrapper function.
Dynamic function building.
It's crazy, isn't it? But what we've done so far is not very interesting or useful yet, because this wrapper function that gets returned is just going to do exactly the same thing as the initial function that was passed in. So we're just calling that initial function with the same arguments. So this wrapper function isn't doing anything different, but I can put other code here to make it do additional things if I want to. So here I'll just put a print statement in.
So since you have to predefine what the function does, really this is kind of a function cloner.
Kind of. I mean, it gives you a slightly modified clone of the function. So at this point, without line 39, yeah, it's basically just cloning the function. But here, by adding this line 39, we're getting a new function, which will first print the name of the function. You haven't seen this before, but every function has a property on it under name, which is just the name of the function. So I've added a little bit of functionality to our inner function to print the name of the function and then the current time. And then we return that function. So now I'm going to try to use this decorator function to decorate some of my previous functions that I've built, the add 1 and multiply by 2. So this is my decorator function, print current time and also. I'm going to call that function, print current time and also, and I'm going to pass in the function that I want to decorate. So we pass in our function add 1, and then it returns to us a new function, which is decorated. And what that new function is going to do is right what we see in here. It's going to first it's going to first print out the name of the function and then the current time. And then after that, it continues doing the regular stuff that the function normally does anyways. So altogether, what this does is it will first print the current time and also add 1, because add 1 is the function that I passed in here. So now I can use this, like, we can print current time and then also add 1. Do we have any other prints up here? Let's get that out of here, get that out of here. Okay. Let's also print the output. So cool. So we can see from looking at the output 1 + 1 that our function still behaves the way we would expect. We're able to pass it the number 1 and it returns the number 1 bigger than 1. So we get that at 2. But it also is doing some logging for us automatically because in our decorator, we have this line print function name and datetime.now. We get that extra line printed out here when we call print current time and also add 1, and it prints the current time and also adds 1.
Wait, where's the adding 1 happening?
Add 1.
Oh, I
This
missed
is
that.
the original
Okay.
body of the
Yep.
function.
Gotcha.
So sorry, I think you're muted.
He's just going to ask on my computer.
When you were talking about function signature, does that refer to arguments?
Yeah.
What's the difference of just saying arguments versus function signature?
So I guess if you want to be precise, the arguments are what you pass in when you call the function. And then when you define the function, you would call these parameters individually. This is one parameter, this is another parameter. Then all together, I would kind of call this entire top line the function signature. Let's see if I can get a more precise answer for you. Yeah, it defines the input and output functions or methods. So I guess in other languages, the signature is more interesting because you also have to declare the types of the parameters and then the output type of the function itself. So in Python, there's not quite as much information up here, but generally speaking, I'm going to refer to this top line of the function with the function name and the parameter names all together. This is the function signature in my mind. What other questions we got? 2 hands up.
So are you just doing it? I think every time you've made a decorator, you've also like put it in a new variable. Are you just doing that for like visual purposes? Can you not just call print current time and one? Like on line 46, you're like creating a new variable, or on 48, are you just doing that for like visual purposes, or can you not just say print current time, also add one?
So in a second, I'm going to show you how to skip this step. But right now, this is actually important because print current time and also just returns new functions. It doesn't actually, do any math or whatever. Add one can add numbers, but it doesn't have the logging involved.
That makes sense.
So I have to call print current time and also with add one passed in as the argument in order to return a function that does both of those things.
Thank you.
Yep. What other question do we have?
I keep forgetting my questions. I have a bit of a, I guess, a side question. With the star arg and the star quargs, we're handing kind of unknown input variables to that wrapper function.
Mhm.
But we can't directly reference those variables because they're unknown. So within the wrapper function, we can't really do anything with them, because even if we tried, if I handed in a function that had, A, B, C arguments, my wrapper function doesn't know those exist. You know what I mean? Like you can't really.
Yeah, so we can't like interact with the arguments too directly. The point is just that our wrapper function should be able to handle any function that it decorates. So like I could have, in this example, just defined this like this. Define a wrapper function that only takes one input argument.
Yeah.
But this way, my decorator can only be used to decorate functions that accept exactly one positional argument.
Right.
Which in this case is true. Add one, multiply by two, both take exactly one positional argument. But maybe, I add another function that takes two arguments for whatever reason. So in that case, I wouldn't be able to use this wrapper function as is.
In this case, the print that you have inside your wrapper function, are you just putting that in there to show that it's being accessed?
No, so actually in this case, that's supposed to be the useful functionality. The idea is that if the application is running really slowly and you want to know what's taking so long, you could write this decorator that just prints the current time and then decorate all of your existing functions so that they print the current time in addition to what they were already doing. You don't have to actually update the function definition for all those other functions. You just decorate them.
So in this, I'm trying to understand kind of contextually where this kind of scenario would be useful. If you have a number of functions already pre-written, but you want to write a higher order function, you can write a function that would like this, print current time, and also use one of my existing functions. That creates a function that is of higher order because it's utilizing a function you've already created.
Yeah.
So you're augmenting almost to the front end of an existing function, something.
Yeah.
So okay.
Cool.
Yeah, thanks. Just had to wrap my head around it a little bit.
It's definitely tricky stuff. I've seen lots of people have been programming for years, and then they encounter this like functional style programming for the first time and just are completely lost. What other questions do we have? A few hands up.
So you can actually access the args with like a for loop. And like the first argument called to it is arg0, and the second one to be arg1.
Yeah, if you wanted to do something with them individually, you could
Oh,
certainly
that is
do that.
interesting. Yeah.
In a lot of cases, you don't need to, you just pass all the arguments straight through. But for sure, if I had more specific expectations, I could look at the arguments or maybe even rewrite them or something.
How would you know how to frame your for loop if the arguments are
For
unknown?
arg and arg.
X and args.
Okay, so it receives args as some sort of array.
I believe it's a tuple.
Oh, okay. Oh, that makes sense. All right.
Yep.
Can you side question, if I may? Can you on like this idea of, you know, a function that creates functions, so to speak? Can you have a function where can you create custom function names through a function? You know what I mean? Like that wrapper function. Could you use a interpolation to determine what that is?
Don't think so.
Okay. Yeah, okay, just curious.
I mean, the closest you can do is having like a function that you attach to an object,
Yeah, okay.
and you can dynamically
Okay.
set the keys in the object, but just
Like
like
a
a
class.
freestanding variable name, I don't think so.
Yeah, okay.
All right, so I just want to give you a second example here. You can print current time and also multiply by 2. So we've created, by passing in multiply by 2 to print current time and also, I've created a function that will print the current time and also multiply by 2. So call that. We can see calling multiply by 2 at this time, and then we also see the output 4. There's a hand up. What questions do we have?
Yeah, so I know my question doesn't really have to do with the decorator part of this, but it is something I'm interested in. So I'm a little curious how this function helps you do what you're hoping to do anyways. Like, wouldn't you need another statement in like the return function that then also prints the time to be able to figure out how long it took to run the function?
So, I mean, the way this is working currently is it only logs at the start of the function. So, I mean, I guess we could do something like so here we are logging the time before and after the function is called and then returning the output. So this would give us like the time difference, you know, and how long this function took to run. So maybe that's a little bit more useful. Make sense?
Yeah, sorry, I know it's not really about the content, but I was like, how does this even?
No, it's important. I understand. Makes it more meaningful, relatable. Okay, so now we can all see how I'm able to pass this function into my function and it returns a new function, which does what I want it to do, right? Okay, so there's one last step here, which is instead of actually writing this line of code where I pass my function into another function and it returns a function, there is a special syntax in Python that does that for me. So let me create a new simple math function. Let's say, so I made a function subtract 3. Actually, hang on. I'm gonna put this down here. So now if I want this function to log the time, you know, with my print current time and also, I'm going to use the @ symbol. This is commonly understood as the decorator symbol. and then the name of the function that I'm decorating it with. And so now it is understood that when I call subtract3, it's not actually calling this function. So that's a little bit weird. You see me write subtract3 here, and now I'm going to call subtract3, 9. Okay, yeah. So we can still get the output, it tells us the return value is 6. But we're also getting those two print statements for when it starts and when it ends. So it looks like that was pretty quick. That's great. That's really what I would hope for such a simple function. So my point here is that this one line here, line 62, is doing the exact same thing as what's going on in line 57. So this is, obviously prettier to read and it's quicker to write, but it's also magical. Like there's no way you can just read this and know what is going on. It's, I think, very bizarre the first time you encounter this syntax. So I wanted to show you kind of the more manual way of how you could implement this using code you already understand. So really, like the only difference between what I've been showing you this whole lecture and just this proper decorator syntax is just this last line here. You don't normally need to actually like pass your function into the decorator function to return a new function with a new variable name. You just put the decorator function above it with an @, and that modifies your function. So it's a little strange because when I call subtract3 here, it's not actually this function being called that I defined on line 63. It's this function on line 63 is passed into print current time and also, and then whatever is returned from that, that is what actually gets invoked when I call subtract3 throughout the rest of my code. It's exactly the same as what I've been doing up here. But this is how it looks with the Python decorator syntax. What questions do we have?
So does that mean you would have to define your decorator function at the top of your code? Because if you try to do what you did on line 62, I'm assuming before your decorator, it's not going to work.
What do you mean? What's not going to work?
So so say you moved your line 63 where you actually define this track 3 above wherever you define the print current time, and also would you get an error because you're trying to reference something that isn't defined?
Oh yeah, for sure. So I would have to define this function previously in my code, either at the top of this file or probably in a different file entirely, and then I would import it. And then this decoration, with the @ here, has to go on the line immediately before my function definition.
Cool, thank you.
Yep.
And just to be clear, the only thing that this allows you to do differently is basically skip line 51 that you have above, right?
Yeah.
Okay.
That's correct. Nobody actually writes their Python code like this. They're just going to use the decorator syntax because it's more elegant, more efficient. But I just don't want this to be magical to you. I don't want you to think you're not supposed to understand this and just write the code how you see it to make it work. This is understandable. And this is what's happening.
I had a quick question.
That's it.
So do decorators only work for user-defined functions, or does Python have like predefined functions for use as decorators, if that makes sense? Like, let's say I had a function that was like, it took a string. Is there like some kind of predefined function that would like take the string and like mutate it or like make it all lowercase or all uppercase as a decorator, or does it only work with the functions that you define yourself?
There are a variety of predefined decorator functions included in Python. So that's why I'm showing you this all today, because there are a few decorators that are useful in object-oriented programming. And I didn't want to just show you the syntax without explaining it. And I figured this would be the best time to explain decorators before we got too deep into Python. So yeah, for OOP in particular, there are a few built-in decorators that will provide us some useful functionality. In general, you're not going to need to define your own decorators. I just wanted you to understand how these are created and how they work.
Okay, thank you.
Mhm. All right, do we have any other questions about decorators? Terrence?
Yeah, I don't actually picture this ever being useful, but could you go back up to line 57? So if print current time and also multiply by 2 was equal to print current time and also add 1, and then you were to do 2 times 2 as it currently is, would the function, would it multiply by 2 and then also add that 1, since print current time and also multiply by 2 is equal to the line 51, add 1, and that function is add 1?
I'm not sure if I can follow you, but I'm not sure if it works the way you're describing. Do you want to try that again?
So if line 57 is equal to line 51, so the function would be print current time and also multiply by 2 is equal to print current time and also add 1. So the line 57's function is multiplied by 2, but since it is equal, well, it's taken in the multiply by 2, but since it will be equal to line 51, which is add 1, and you call it up on line 40, which takes in any number of arguments and key args, would it multiply by 2 and then add 1, since it's basically taking in 2 functions?
I mean, if I'm understanding you correctly, you can like double decorate a function. So like, well, let me think here. So we've got add 1 that we pass into print current time and also gives us print current time and also add 1.
Line 57 equal line 51.
So I could pass this function into print current time and also, and so that would basically give me a new function that prints the current time twice and then runs the function.
All right, I get it. I get it.
All right. Do we have other questions?
I did. So I just wanted to clarify, you used a separate example on line 63, a subtract 3. If you were to attempt to do that exact thing with the add 1, I guess what I'm trying to get at is, do you need to be careful that the function, if it already exists, we want to use the shorthand syntax in the 62 line block, but if it's already previously in our code and you print add 1, pass in 1 for using your example, there would be 2 competing calls there, since you have the add 1 function above and then you have the decorated add 1 function below with the shorter syntax. So is that, am I understanding that right? That you'd have to make sure it's not already in your file?
Yeah, so that's kind of a weird thing about what the example I've shown you here is that, you know, like for example, line 51, we're creating our print current time and also add 1. But before line 51, we have our add 1 function. So both a decorated and undecorated version of the add 1 function exists in this program, which is generally not what you want. So if we're actually using the proper decorator syntax, we have to do this at the time the function is defined. And so then therefore, every single call of that function is going to use the decorated version. If I define the function with a decorator like this, there is no opportunity to use the undecorated version anywhere else in the code.
So you would almost never do this with functions, that, because you mentioned, you said no programmer will ever do it this way, is what you said before. Like
Right. Practically speaking, I would not decorate a function manually in this way. I just wanted to show you what the decorator syntax is actually doing.
Right. But so you almost never find yourself in a position where you want to decorate functions that already exist then? You would want to only do it with new functions that you haven't defined yet?
Um,
I think it's the opposite.
Because you said that you can't have an undecorated and a decorated basically in the same file, which is what I was getting at before, right? Because then you'd be calling the same function decorated and then, or
Right.
undecorated and then decorated. But then you said, so I mean, maybe I'm saying this incorrectly then, but if you're trying to do this with a function that already exists, but you want to use the shorthand, you would just do it on a different JavaScript file than the one where the undecorated was originally defined?
I mean, if I want to use the decorator, if I want to decorate a function, you have to, if you're going to use the decorator syntax, you would do it initially when the function is defined, so that everywhere else in your program, it's using that decorated version. There shouldn't be any like confusion about whether using the decorated or undecorated version. Just as long as you define your functions like this, and then you should know what functionality you're getting. Not sure if I understood your question completely, if that helps.
My question might help, because I
Okay.
wanted to actually clarify as well. So if I have a program that has 20 functions in it, and I sitting here and I go, you know what, I want 5 of these functions to print me a date time. I can create that wrapper function up near the top of my code. And then I can go through and find those 5 functions I want to augment with that date time. And I would add this decorator above those functions, and which would
Right.
augment those 5 functions with my new wrapper code, right?
Correct.
So that's how I would implement this rather than creating new variables of that function. I would just create the wrapper and then attach that wrapper to existing functions using this at
Right.
syntax. Okay.
Because also figure that like those 5 functions are probably called, maybe hundreds of places throughout the code.
Right.
So it would be a big hassle if you actually had to rename the function and then change that in your code. So
Right.
that's another great thing about the decorator syntax is it changes the functionality of like a function name that already exists throughout your code base. So you don't have to update when you call it, you just update the definition of it.
Did that help, Alicia?
Mm-hmm.
Okay.
All right, what other questions do we got? We move on. Let's move on. This file is getting a little cluttered, so I'm going to open a new file. So now I want to talk about methods in our classes a little bit. So we've talked about instance methods, which are the things that our objects can do. Those are by far the most important methods in an object-oriented class, but there are other types of methods as well. So just for a refresher, so we had methods like bark, speak, fetch, for our dog class the other day. These are things that every dog knows how to do. I'm sorry. And then also things like color and sound. These are instance attributes. These are properties that belong to an individual dog. But it's also possible to define data in an OOP class that doesn't belong to any specific member of the class, but belongs to the class in general. So let's see an example of that real quick. Make a dog class again. All right, so we've got our basic dog class here. And make a dog, print out his name, great. Should look pretty familiar based on what we did yesterday. But all these attributes I've defined here, these are specific to the individual dogs. So sometimes you want to record information that doesn't belong to a specific member of the class, but belongs to the class as a whole. So add species here. So this is the scientific name for the dog species. So here I've defined this up at the top. This is kind of like a variable local to this class. This is considered a class attribute or a static attribute. Think in Python, that's more specifically a class attribute. So I think you could make the argument, honestly, that this could also belong to individual dogs, but I'm just trying to give you an example of something that would be a class attribute. So let's kind of imagine here that this is a description of the dog class itself. This is the species of the type of dog that we can create here. So this is information that belongs to the dog class in general, not any specific dog. So we can access that by printing fido.species, but I think it makes more sense access it like so. So both of these will show you the same information. So some people kind of think of it as like a fallback or like a backup or a default. If you access a property on the instance and it doesn't exist, then Python is going to look for it on the class itself. But in my opinion, if you're expecting this data to be on the class itself, then just I would look for it on the class itself. So if you're expecting it to be on dog, I would, just look for it here. I think it's kind of odd that in Python, it'll automatically give you a class attribute if you try to access a property on an instance that doesn't exist. That's not exactly what I would expect.
Because it's an inherited trait, right? So it's still going to produce the species.
I don't want to use the word inherited in this case because that is a very specific meaning that we'll cover tomorrow,
Oh, okay.
but it's similar.
So does that mean you can't make a self.species inside of Fido?
You can,
Well,
but then checking fido.species would give you self.species. And then the
Okay.
only way you could access the dog species is with dog.species.
okay.
All right. So yeah, say class attribute or a static attribute. You don't need them every day. They're not tremendously useful, which is why I didn't show you this on day one, because I didn't want you to get like hung up on things that you're probably not going to use for solving the exercises. But sometimes these are useful, and certainly I would say that this is a good question that you might be asked about in an interview. If you tell someone like, oh yeah, I know object-oriented programming, they'll might ask you like, okay, what's the difference between an instance attribute and a class attribute? And so you can tell them, one belongs to the instance itself and not, or yeah, and then one of them belongs to the class and not any particular instance. All right, so let's see another more interesting example. This is just using attributes, but it's more fun when we're talking about methods. So we're gonna make a class for pizza. So we can initialize our pizzas, great. So a very important question when you're ordering a pizza is how much pizza am I getting? So it would be good if this pizza was able to tell you its area. Or its size or whatever. But let's say that as part of the pizza telling you how big it is, we need to know how to calculate the area of a circle. And so you might say that calculating the area of a circle is not really something that's specific to an individual pizza. That's kind of just generic mathematical functionality. And so there doesn't really need to be an instance method for a single pizza understanding, geometry of circles. But maybe we could just put that as a static method on the class itself so that it's just kind of a generic functionality that we can access as needed. So I might first create a static method. So this is the area of a circle, just pi times the radius squared. Probably a better way I could have phrased that, but that's correct math. And then so for calculating the area, this is the part where the pizza is actually aware of itself. So here we've got a pizza. Let's say I want to know the area of this mushroom pizza. Cool, so that's the area of a pizza that has a radius of 10. But also this functionality, circle area, because it's a static method, other parts of my code can access this as well. So let's say I was building, I don't know, a dinner plate or something. And we want to know, how big that is. It's also a circle, it has a radius. So we can just call so, let's say plate has a radius of 4. We just call pizza.circle area 4, and that's going to give us our answer. Cool, so that's just 50. Is that inches squared? I guess I didn't specify units here. So in this case, we're saying that, we have a different need, a different use case where we have to calculate the area of a circle. And we know that that functionality exists in the pizza class because the pizza just generically knows how to calculate the area of a circle. So we can utilize that functionality for calculating the area of other circles. Question?
Yeah, can static methods only be defined inside of a class, or can you define them anywhere inside of your code?
They have to be defined inside of the class. They are part of the class. They're just not part of the instances themselves. So here, like I'm able to access self.circle area just because when you access a property on self and it doesn't exist, Python will look for it in the class. So it's important to understand that that is actually what's happening here. This circle area method doesn't actually exist on self. It exists on the pizza class, but it's just that pizza isn't getting passed in here directly. We could just call pizza.area, I guess, or pizza.circle area. Or wait, hang on a second. Yeah, okay, that's correct. John, do you have a question?
Yeah, so using that static method, that's the decorator, right?
Yep.
So that decorator behind the scenes is basically doing the same thing you did with when you did, Canis Familiaris. It's just taking it kind of and putting it above like the definition outside of the object.
Yeah. So, normally just this function defined like this would just be a regular instance method, just like area. But I didn't want an instance method. I wanted a static method. So by adding this decorator, my circle area function gets passed into this decorator function, and then it gets transformed somehow. I don't exactly know what happens internally, but the function that is returned behaves differently. And it's going to give me a function that belongs to the entire class and not individual instances of the class.
All right, thanks.
Mm-hmm. Do we have other questions?
What does that say over to the right on your notes? It's cut off. It says so we can read. There we go. Thank you.
Yep.
Is static method, is that associated with the math module?
No.
Okay.
I just needed math to get the value of pi so we can find the area of a circle.
I just tried doing it in my own, but it doesn't really do anything. Gives me an error. I'll see what I did wrong.
Lowercase m, I don't know.
Yeah, I'll see what I did wrong.
Are your indentations correct?
It's definitely something to check. Do we have other questions? I saw a few hands up.
Yeah, I have a question. So what's the benefit of making a static method within a class as opposed to just defining that function outside of the class and just referencing that function from within the class? Or does it not work that way?
I mean, you could do that. It's mostly for organizational purposes. It's just if conceptually this function like belongs in the class and you just think like that's where you should put it, they're like, conceptually related. And so you just want to put that code close to related code. You could make a static method. You're certainly right though, that like static methods don't really like do as much work for us. They're not really saving us a whole lot of trouble compared to just having a regular function defined outside the class. So it's just for organizational purposes. Whereas in contrast, using instance methods are really powerful because that lets us, define a method once that can be called with each of our instances passed in as self. So that's a nifty little shortcut that helps us, build bigger, more complicated programs. So yeah, instance methods are more useful in general, but this is important to know still. Sorry.
Can I throw something in, Raphael?
Sure.
Yeah, and tell me if this makes sense. So to that question, to add to your example, like with the pizza, another static method might return a list of all possible ingredients for any pizza. And then like you were saying about just organizing stuff, if we're like working with the pizza class, that way, whenever we have a pizza, we have this method available that can just return a list of all available ingredients as like utility.
Yeah, that sounds useful. If I was making a pizzeria, I might expand my pizza class to do that. So you don't have to just like know offhand what the valid ingredients are. The pizza class should be able to tell you what you can potentially put on a pizza. Cool, thanks.
Yeah, do you-
Also,
That's
isn't
kind of
this-
what we're doing with the circle area too, where it's like every pizza, you calculate the area of a circle, the area of it the same way.
I'm sorry, can you say that again?
I was just saying that's kind of what you did with the circle area method too, because it's like every pizza, it's going to be the same formula to calculate the area of it. You know, so you want to kind of lock that in one place.
For sure. Dalton?
could you, I'm sorry, I'm just having a hard time kind of following. Could you just, so you pass in the radius parameter, and then the area takes that, and then does the circle area ever mess with the radius or no?
Sure. So when we call circle area, we're passing in this value self.radius, which is, you know, whatever is assigned when we initialize the pizza. And then our circle area method, it's accepting one input parameter. Here we're calling it R. Maybe I can just be a little more verbose. So yeah, we're passing in here, and then that's how it's accessible in our static method.
Okay, and then that gives you your radius by timesing it by 2, or I'm sorry, raising it to the second exponent and then timesing it by pi.
Yep.
Cool.
All right, any more questions on static methods versus instance methods?
Can I kind of like reinforce myself, make sure I'm like fully understanding?
Go for it.
So it's like the static is where it's not in its own individual instance of the class, like Fido. It is, you know, within the dog. So Fido does have area in it. And then like if you had Sally as a dog, Sally would have area, but each Fido and Sally don't particularly have circle area, but the class itself has circle area.
Right.
So each individual doesn't have it per se, but the class itself does, and that makes it shared.
Yeah. Here's maybe another example that might be useful. Sometimes you want a class to keep track of its members. So we'll create a static attribute here, all dogs. And then as part of the init, we can do dog.alldogs.append self. So here I print dog.alldogs, and it's telling me I've got one dog object and another dog object. It's just a list of dogs. If I want to see that a little more prettily, we'll just return the name. Oh, is that not gonna show it to me still? All right, whatever. So not gonna worry about the output being pretty at this point, but the point is that no individual dog is responsible for keeping track of all the other dogs, but the dog class itself might be interested in keeping track of those things. So in our dog class, I've defined this static attribute, class attribute called all dogs, just an empty list. And then when we initialize a new dog, last thing we're going to do is append that list with the newly created dog object. So now after the fact, we can always keep track of all the dogs that we've created by just looking at our all dogs list on the dog class.
Is self
But how
need,
would you actually see them? Because that, like you mentioned, the fact that it's an object doesn't help us at all. So is the only way to loop through them?
I mean, that's one way. So yeah, when I print them individually, it actually uses the str method. Or, you know, you can look at whatever else you want. Dalton?
Sorry, because when you brought up that example, I won't say it confused me more, but I just want to go back to the pizza again. So every time you create an instance of the class, it's going to call like everything. So what would be I don't know, maybe explain this, but what would be the purpose of having that static method static as opposed to just having another area type function that's not a static method?
So by having this a static method, that means that I can access this function without actually creating any pizzas. So like in this situation down here, I'm saying that maybe I needed to print the radius of a dinner plate or something that's not a pizza, but I know that we already have this functionality somewhere else.
Oh.
So I just borrowed it. I'm just gonna quickly print out the area of something that's not a pizza by accessing the pizza class. I don't even have to make any pizzas in order to do this. I'm just kind of borrowing that method real quickly.
Also, if I could pitch in, like, this is an example where it's a one-line return, right, on line 35. But imagine if this was like a really complicated function. Every time you created a class, you wouldn't want to create, I mean, every time you created an instance, you wouldn't have to want to retype the same exact function over and over if it's like a 10-line function, when instead you can have the one-line return self dot function and pass in this one self dot parameter.
yeah, like if the function returned how many slices were in a pizza of a given radius.
Okay.
Can you scroll up so I can see that dog thing again, though? Okay, thanks.
Yep. All right. So at this point, I think I'd like to move on, talk about our last topic for this morning. We're going to talk about getters and setters. So this is another kind of slightly more niche topic in object-oriented programming, not as core as instance methods, but this is important. It's pretty cool. I think it's good to know about. So the problem is that, you know, you might need to modify an instance variable from outside of the class, you know, like the dog's breed or age or whatever. So in simple cases, you can just assign to an object's properties. So let's see here. We've got a person class. These people should probably have names too while we're at it. Say Alice equals person. And age equals 10. Cool. So this shouldn't be too surprising. I've created a class, created an instance of that class. I've assigned a new value to one of her attributes and then printed it out. And we can see that the change has taken effect. She is no longer 0. Her age is now 10. So that's great. However, occasionally, as your application becomes more complex, you might need to add extra rules about how these properties can be updated. So if our class is well designed according to OOP principles, such as encapsulation and abstraction, these rules should be defined in the class itself. Other code outside of the class shouldn't need to be aware of them. So we can achieve this using getters and setters in Python, using another decorator called @property. So let's consider kind of this use case, the problem here that I'm going to try to solve. I've got this person class and we can set their age. And there are other parts of the program where we're setting their age, like here on line 8. This is not inside of the class, just setting Alice's age from elsewhere in our program. But I want to add some extra logic that when the person's age becomes greater than 99, then they die. This is one of those like weird dystopian kind of future novels where like, people get sent to the nursing home at like age of 100, but it's actually an incinerator, or they just like ship you off to Australia or whatever. So this is one of those kind of societies. Everyone has a cutoff at 100. So we need to know what their age is set to. Now, in theory, like I could put that code over here. Alice.dead equals true. But remember, I just said that my point of doing all this is that the rest of the code shouldn't need to know or care what happens when age is set to over 100. Or I'm sorry, so age is 101, Alice.dead equals true. So this works according to my logic, but the rest of my program shouldn't need to know what happens when you turn 100. The rest of the program should just be able to assign values to these properties, and then the person class itself handles any details. So we're going to take that out. And what I'm going to do now is I'm going to update my class definition, because I no longer want people to directly assign data to the age property. I want that to be kind of an internal private variable. And then we're going to just use functions for updating that internal private variable. So we're going to do a little bit of refactoring here real quick. So instead of age is equal to 0, we're going to call this underscore age. So it is a different property now. Looks the same, but it starts with an underscore. So this property here, Alice.age, that is not the actual property that exists on the instance. What it is, though, okay, so this is how you define a getter in Python. Use the @property decorator, and that says that this function here, age, is to be used as a getter. So it's not intended that you actually call this function. So I'm never going to write Alice.age. You don't do that. But rather, whenever someone tries to just read the value of age, it's going to call this function. So I'm just going to print Alice.age. Okay, so to refresh, age is a function. I'm never calling it though. I'm just accessing it as if it were a property. Now, based on what we know about functions already, this shouldn't work. This should just tell me like, yep, Alice.age is a function. Great. What do you want me to do with it? But I didn't call it, except because this is a property, this is a getter. When I try to access this property, it's actually going to call this function. Cool. So it still gives you the value because we said here return self.age, which is just this internal age variable. But it also calls the function and calls this print statement, getter method called. So in this way, we're able to change internally what happens when you assign to age, but the rest of the code doesn't need to know or care about that. I didn't have to update line 17 when I refactor this from not using getters to using a getter. So you can also call this encapsulation because this variable now is internal inside the class and code outside of it doesn't deal with it directly. They don't have to deal with all that extra complexity. You could also consider this to be a form of abstraction because all the extra work that has to happen when the age changes, other parts of the code don't think about that. You don't really have to understand it unless you're looking at the person class itself. So the person reading your code gets to choose what level of detail they care about as they're reading it. Okay, but now let's see the second half of this. I showed you the getter, and this file is called getter setters, so you should be expecting something else coming here. Call this at age.setter. And I'm going to define another function, again called age. So just like using at property here declares age as a getter, using this decorator at age.setter declares that this function is to be used as a setter. So that means that whenever code outside of the class tries to directly assign to the age property, well, you can't actually do that. But what it does instead is it calls this function, and then whatever we try to set age to, that gets passed in as this argument. So then all we have to do is first actually update the internal variable. So whatever was passed in, whatever they tried to set age to, we're going to actually set the age to that. But then we're going to do some more logic too. So we can check here if the age is greater than 100, whatever they tried to pass in. Then in addition to setting self.underAge, we're going to set self.dead equals true. So we'll set Alice's age to 101, print her age, and check if she is still breathing. Cool. So see, the getter method is called, her age is 0. Then we, why not? Let's put a print in here too. All right, so the getter method is called, it's 0. Then we try to set Alice's age to 101, which invokes this function, def age. And we see that print setter method is called. Then we print Alice's age, which we were able to set that successfully just by assigning it here because it called our setter function. And then when we print out alice.dead, that tells us true because this setter function updated her dead property because the age she was set to was greater than 100. So in this way, we have encapsulated some extra complexity inside of our class itself. There is logic for what happens when you reach a certain age, but other parts of the code don't need to know or care about that. Other parts of the code can just say like, hey, it's a year older. So Alice, you're 1 year older than you were before. I'm just going to assign it to you. And they don't have to know what that actually does to Alice. But Alice internally, she knows what happens when she gets older. She knows to check her age if it's over 100. So this is a really powerful technique if you're developing a big application, because you don't have to make this decision up front. You can start your application in a kind of naive way where you just assign directly to these properties. And then you can decide later on, like, hey, this is getting too complicated. We need extra logic to happen when you assign to these properties, or we need to check if it's okay to assign to these properties. And instead of putting that extra logic everywhere else in the code where you're assigning these properties, you can just use these decorators. You can add these in after the fact to create getters and setters for what used to be just simple plain attributes. And again, I know this looks a little bit weird because I've defined two functions with the same name, def_age, def_age, but Python is able to tell them apart because A, they're passed into these decorators. So these are actually different functions. This one is decorated by @property. This one is decorated by @age.setter. But also, oh yeah, Python is able to tell them apart because one is only invoked when you assign to age. And then the other one is the setter is only invoked when you assign to age. And then the getter is only invoked when you try to retrieve the property. So yeah, that's getters and setters. I think they're pretty cool, potentially very useful. Other programming languages, I think, rely on these a lot more heavily, but it's still a useful feature to have in Python. So that is all the content I've got for you today about object-oriented programming and getters, setters, decorators. What questions do we have?
Got a question about the syntax in the setter. So you have @age.setter. So that age part, is that referring to the definition underneath or to the _age above?
I believe it's referring to this age previously. It's referring to the getter.
So then you actually have to have this or @age.setter, you have to have a @property as well. You can't just have a setter without a getter then?
I believe so.
Okay.
Just gonna try to comment this out, see what happens. Oh yeah, so here at age.setter, now my editor is yelling at me, age is not defined. So yeah, I'd have to refer to this age up here.
Okay, thanks.
Yep. What other questions? Saw a few hands up.
Yeah, so I actually have 3 questions. So my first question is, and I don't even know if this is an ideal question, but how often would you find yourself in a position where you've got this class that you created like a while back and you can't remember all of this internal syntax of how to get and set and do all of these things? Can you just, how do you print, or is it as easy as just say print person with a capital person and it will then reprint all of this internal stuff for you, or would you already know where this class is located, and then if you can't remember, you'd go to that file?
Yeah, you should just read the code. I wouldn't expect to understand how a class works from like executing the program. So like, yeah, you can print person, but I don't think this is going to show you anything too super useful. Yeah, it's a class. In JavaScript, if you print a function that you've defined, I think in some cases it'll actually show you the full definition in the console. But I'm not sure how to get anything useful like that out of Python. At the very least, though, there's super handy dandy functionality in your editor for go to definition. I'm trying to see where this is. And I don't know. Okay, anyways.
Yeah, I would even just do the global stuff, just to throw that out there.
Pardon?
I think there's some, well, is there like there's a global search functionality?
I mean, you can definitely go in this little box over here and just search person. And that's going to show you everywhere in your code where the word person exists, which is possibly going to give you more results than you want. So there's also a shortcut. So I'm on the person class here. I'm just clicking go to definition, and then it jumps me up to the top of the page where this was defined.
Wait, where did you click that?
So I did that with a Vim shortcut. I know that there's a native way to do it with just the VS Code commands, but I don't remember what it is because I've learned Vim a long time ago and I've learned a whole bunch of other editors since.
That sounds super.
Go to definition, F12. Okay.
Okay.
Yeah.
Yeah, that will definitely answer that one.
Yeah.
The second question I had is it pretty common syntax then that or I guess maybe it's actually required that the getter and setter have the same, maybe you just showed that they have to have the same function name. Like you couldn't have like age underscore getter, age underscore setter, like it has to be the same name.
Right. It's got to be the same name.
Okay.
Because remember also from outside of the function, they're both the same. It's just age.
Okay. And then my last question actually isn't about this. So if anybody else has questions about the getters and setters, but I noticed that in today's notes, you skipped over the class methods with like margarita and prosciutto. But when I read over those, I really didn't understand what you would then do with those. Like, are you then supposed to like print margarita and it will then print the ingredients? Or like, what would you, after you have that there, how do you then use that information?
You're looking at the margarita method specifically, you said?
Yeah, so would you just like later on to get that information, are you just printing margarita or like, yeah, I don't really understand how you would then use that the margarita has those ingredients. Like, are you defining a variable as margarita or what are you doing?
Okay, so let's take a look at that.
Well, does anybody else have questions on getters and setters before I completely hijack the lecture?
Cool. So this is telling me it's a pizza object. Let's look at. So the idea is that.
That's the part I was missing. Okay, thank you.
So yeah, the pizza class is, generic, can make any kind of pizza with any ingredients. But let's say we want to specifically have the functionality for making specific types of pizzas. So we added a class method. So this doesn't belong to a specific pizza, but it's part of the pizza class in general that makes one specific type of pizza. So this method is going to get the class itself passed in. So that's pizza. So returning class 8 mozzarella tomatoes, this is basically just invoking the pizza constructor itself, but with very specific arguments. So instead of letting the user choose what to pass in when this is invoked, pizza.margarita only makes one type of pizza. So in my opinion, class methods are not tremendously useful. I like really would struggle to tell you when you would use this instead of a static method. Because they're really like 99% the same, except that the class method gets the class itself passed in. The static method does not get the class itself passed in. I mean, you can still access it with pizza. So you do still have access to the class itself, even if it's not explicitly passed in. This can be more useful in like some inheritance situations. So sometimes in more complex problems, you might prefer to have the class be passed in instead of just access it directly. But I have not really encountered situations like that. Also, another reason why I don't really care so much for class methods is that this is really just like a Python specific kind of feature. Static methods are like a classic OOP kind of thing. So someone who has never written Python or JavaScript, you know, maybe they're like an old school Java developer and they're gonna give you an interview on object-oriented programming. They might ask you about static methods, but they're not gonna use the term class methods because this is really just a concept that only exists in Python. Just the fact that they have this distinction between class methods and static methods, like only exists in Python. For the most
You
part.
literally achieve the same exact thing by changing line 38 to static method.
So if I wanted to do that, then this class is no longer being passed in. I could just do that.
Okay.
Yeah, it's not anything groundbreaking. What other questions have we got? The chat looks pretty quiet. So yeah, I guess people have no more questions for today. That's cool. So I'm sure I just fully
Can you
answered
scroll
everything.
down just a little bit?
Pardon?
Can you scroll down just a little bit? Okay, thank you.
Yep. And as usual, all this code is going to be up on GitHub in the demos repo, so you can review it at your leisure. All right, so if we don't have any more questions, I think we will conclude the lecture at this point.